Bitcoin transactions consist of inputs and outputs. And basically, a transaction can have any number of inputs and any number of outputs. The inputs come from earlier outputs. So each input needs a link to an earlier transaction ID and an output number. And inside each input and output are scripts, basically. And an output contains a script and a value representing the number of Bitcoins to be sent. So in order to validate a Bitcoin transaction, one of the most important steps is to actually run the scripts in all of the inputs and the corresponding outputs. So in order to validate a particular input, you run the input, which typically involves pushing something to the stack like a signature. And then you run the output that it's spending from. And that specifies the conditions of actually being able to spend the money. So what I want to talk about in this video today is actually how to format scripts. We're not going to go into detail in the script interpreter yet. That will be in a future video and future documentation. All we want to talk about is basically the basic ways to basically read and write scripts using BSV. So what I have here is an example of an address. And this is what the script looks like that actually spends to an address. So although you want to spend money to this address, for example, the thing that actually goes inside of an output looks like this. This actually is the address encoded differently. So this is actually the hash of a public key in hex instead of in base 58 like this thing here. And so what this script says is op-dup, so this means duplicate the top item on the stack. Hash 160 means hash that value, which is actually a public key. I think I might have this one backwards, now that I think I'll have to change that, but anyway. Then what it does is it then pushes this thing to the stack, confirms that they're both equal, and then runs check sig, which what that says is now the next item on the stack needs to be the signature. And then confirm that the signature corresponds to the public key, which corresponds to the transaction itself. So the input looks something like this. Again, I might actually have this in backwards order now that I think about it, but it doesn't really matter. You get the idea. The input just pushes two things to the stack. So it contains a public key and a signature. I'm not showing real examples of them, but we've got substitutes here. Using the library, here is how we convert an address into a script. So I've got example code here to convert this into a script. And then as well as how to convert it into a hex formatted script. So there are two common ways to format scripts that you actually care about. The first is ASM. And this, I believe, just means like assembly. And it's just the idea of writing down a script in a human readable form, because you can actually read the operations. This is just data, so it's not like data is really necessarily human readable. It just is what it is. But the opcodes themselves are actually human readable. So it looks like a little programming language. You can actually read the operations. But of course, inside of a transaction, it's actually in binary. So in order to create a transaction and things like this, you often have things represented in hex, which is very easy to convert to and from binary format. The final thing you should be aware of is basically how to read them in and write them back out. So I've got here an example of reading in, both from ASM and from hex, and showing you what that script looks like. And then one final caveat, which is that there is a two-string, or I'm sorry, wrong section to go through. Somewhere I have this written here. There is a two-string method on a script, which you actually shouldn't run, because it'll actually give you a different format than ASM. These are the two standard ways to print scripts. It's either in ASM or it's in hex. And you shouldn't use the two-string one. It's a long story. I'm actually one of the primary authors of this library, and I created a custom script format that was isomorphic. So it's wonderful that it's isomorphic to the hexadecimal representation. However, it's not standard, and so we don't recommend using it just because it's only in this library, basically, and you never see it anywhere else. So I don't recommend using the .2 string on the script object. Always use .2 ASM and .from ASM, or .2 hex and .from hex. Okay, and finally, the script has a toAddress method. So basically, if you happen to have a script that is a pub key hash output that looks like this, you can easily get the address from that. Okay, so that's all I have to say about the documentation there. I think it'd be interesting if I just quickly went through in a terminal and actually tried to reproduce some of this stuff. So let me open up my terminal here. No, I do not want to install the update. We'll skip this version. Okay, so let me first open up my terminal. As usual, what we do is we load the library itself. Now what I want to do is I want to generate a new address to begin with. So let me just do that really quickly here. Equals bsv.address from I think there's an easy way to do this. I think I can say var priv key equals bsv.private key from random, and I think there's a priv key .to address, if I remember correctly. Yes. So we've got my address here. Address equals priv key .to address. Looks like we're using deprecated inspect method that we'll have to fix inside the library. Okay, so we generate an address. Now if I do address.toString, okay, so there we go. We've got a wonderful address there. Now what I want to do is I want to convert this address into a script. So let's say something like var script equals bsv .script from address. And there we go. So now I've got the script form of that address. This is the thing that would actually go inside of an output. Of course, you can write scripts by hand, and I'm not showing what all the opcodes are. We'll see this in a future video where we overview the script interpreter. But there are many, many operations that you have access to. You know, in the words of Craig Wright, script is fairly much standard Forth. So Forth is a stack-based programming language where basically you have a stack. You can push and pop things from the stack. That is the memory. There's also an alt stack. You can move things from the primary stack to the alt stack and vice versa. And there's no heap. That means there's no way to just set a variable or something like that the way that we're used to. All there is a stack and an alt stack. Anyway, those are details that we can explain in further videos. But in any case, the point is this is just a sort of the world's most trivial script that you actually see inside Bitcoin very frequently, but you can do far more advanced things that we'll explain later. Okay, so anyway, we can also look at the 2-hex version of the script. So again, this is like what you would actually, like if you were to format a script as seen inside of a Bitcoin transaction, it would look more like this, because it's binary. This is the closest we can get really representing binary here in the form of a string. Okay, so anyway, what I want to do now is, let's show you what it looks like to actually input a script. So you might also need to do something like this, from ASM. So that's a way of pulling in the script, and of course we can do the same thing with hex as well. Okay, and I guess that's it. So that's an example of how to use this. We've now discussed how to format and how to read and write scripts and convert them to and from addresses. What we haven't yet discussed is all of the more advanced things that you can do with script. Now, a lot of the advanced things are actually not enabled right now. At the time of this recording, this is November 18, 2019, we have not yet experienced the Genesis upgrade, which is going to remove a lot of the caps on script and allow us to actually do some of the more advanced things. There are all sorts of caps. I don't really want to go into it right now, but the point is that there are a lot of limitations on script that are going to be removed, and we're going to be able to do more advanced things very, very soon, early next year in 2020. All right, so that's it for this video, and look out for the upcoming videos and documentation on the script interpreter and transactions and all sorts of other advanced things too. All right, thank you for listening.